Dear speakers, dear colleagues, dear Industrial Ecology community members, welcome to this IE Day session 2024 on the limits to downscaling, the pros and cons of absolute sustainability assessment of products and services. We have in this 1 hour session 3 eminent speakers. Thank you very much for taking the time and joining us. We have 𝐒𝐞𝐬𝐬𝐢𝐨𝐧, Distinguished Professor for Urban Environment and Human Ecology at the ANU based in Canberra, Australia. We have 𝐒𝐞𝐬𝐬𝐢𝐨𝐧, Research Director at CERET, the Centre International de Recherche sur l'Environnement de 𝐓𝐬𝐬𝐚𝐺 in Paris. And we have Reinhard Hayongs, an LCA pioneer and now based at the Vrije University in Amsterdam. All of you have authored major contributions to this very topic during the last years, actually this year, and Reinhard, your comment appeared a few years ago in the GIE, and I'm very happy that today we can convene and first have your presentations and then discuss. So I will now stop my video sharing. And that means we can already start with your presentation, 𝐒𝐞𝐬𝐬𝐢𝐨𝐧, and then we'll have a quick clarification question. If there's any else, we'll move on to Frank, then to Reinhard, and then join a common discussion until we fill the hour. So thank you very much, everybody, for being with us and enjoy the session. 𝐒𝐞𝐬𝐬𝐢𝐨𝐧, the floor is yours, please.
Thank you, Stefan. Good morning, good evening, good afternoon, wherever you are, everyone. Thanks for coming to the session. And thank you, Stefan, for the invitation. I'm really excited joining this because our work is very much related to this community. And I was actually thinking about reaching out to the industry ecology community. So it's a great opportunity. So I'll be presenting mainly based on our paper, which is translating Earth system boundaries for cities and businesses. So this is part of the Earth Commission work, which was trying to scientifically define boundaries for stability of planet and also safety of people along the same sort of unit. So some of you might ask, what's the relationship between this safe and just ESB with the planetary boundary framework? So this is basically extending planetary boundary framework by integrating the social science or justice perspectives and then, try to quantify along the same unit. So this is the paper led by Johan Rockström, which was published last year in Nature. And if you need to know a bit more, please go find this paper. I'm not going to go into detail. So in this paper, basically we found 7 out of globally defined boundaries are already breached. And we quickly realized that, the Earth system boundaries that we defined, they really need to be linked and translated for actors if, they are to guide the practice of these actors. And here we think cities and businesses are the key actors. So we decided to focus on these 2 actors. And this is not only because most of our environmental impacts can be traced back to cities and businesses, but also because of their potential agency that they can actually really take, a nimble sort of action if they determine to do so. So within Earth Commission, we have this working group 5, which is on translation, and I've been leading this working group. The working group has been composed of 15, 16 internationally, composed researchers who are interested in this topic. So then we looked at existing literature where we started first. We found there are quite a number of studies, but mostly inconsistent across different cases. And also they are not comparable. And they are very often at different spatial and temporal scale. And with very implicit and normative.
𝐒𝐞𝐬𝐬𝐢𝐨𝐬𝐬, can I quickly ask you, do you have a shared screen or are you presenting without slides?
Oh, I am sharing screen. I thought I shared. I'm so sorry.
So far it went well. I think now we need to switch to the slides, yeah.
Can you see it now?
Perfect, thank you.
Oh, I'm so sorry.
Oh,
yeah. So this is the paper, Earth Commission paper led by Johan Rockström. And this is the one that we show, we have breached 7 out of 8. And then we started looking at how we can go about this translation. So here I would like to really emphasize although the session title is downscaling, but I would really like to preach that please let's use the term translation, because in our mind, this translation is much, much more complicated than just downscaling something across different scales. So we call it cross-scale translation. So when we looked at existing literature, there are, we know there are quite a number of studies, but mostly, inconsistent, incomparable, and they're at different spatial and temporal scale. And most importantly, many of them have very implicit normative assumptions that are not really made clear. So in this sense, we have started to look at the literature and try to identify what are the state of the knowledge and where are the knowledge gaps in terms of translation. So in this paper we published in 2022, as a comment in Nature, we have identified 7 knowledge gaps in terms of cross-scale translation. And this includes, for example, the need to really develop a common procedure that can be robust and then, transparent and comparable. And also the need to focus on interactions. We cannot pursue these boundaries one by one, but we have to look at them as one system and then really understand the interactions. And also we need to acknowledge the dynamics. This is more of a temporal scale consideration. And also we do need to allocate the responsibilities and resources for justice and equity. And we also need to support our monitoring and accountability. Once we have, downscaled or translated a budget for actor, then, and then they set this science-based target, we do need to support their monitoring and accountability of those set target. And then it is really important to establish governance mechanism to ensure that these actors are actually acting along those translated boundaries or set, the science-based target. And of course, this all needs to be based on a designed incentives, because right now we don't have a mandatory sort of framework to force these actors to take actions. So our work within the working group has been really trying to advance some of these knowledge gaps we identified. And this paper, which was published early this year, in January this year, in Nature Sustainability, is really one of the culminating sort of output from our working group. And this is the same as the title of my presentation. So here, what we have done is we review and synthesized existing literature, and we attempted to develop a common principle of translation. And then we also try to present a protocol of such translation. So here are the 10 principles of translation that we have identified. So I don't think I will have time to go into details of this one by one, but you can see, for example, the first principle is that the translation really needs to be scientifically rigorous, and they need to be transparent, and they need to be just, they need to stand the test of, just consideration. And also they need to be systemic, and they need to be sufficiently safe. And I would like to spend 1 minute on this sufficiently safe. So what this means is that when we allocate the shares of responsibility to actors and then hoping them to take action, I mean, we all know some of them will eventually fail, right? So what we are trying to say is probably we should build in the buffer from the very beginning so that we know, even, we don't know, maybe 20% or 30% of the actors, even they fail, probably collectively we can still stay within the safe and just boundaries. So that's what we mean here by sufficiently safe. And this needs to be context sensitive. And this is why we are really against the use of, simply using the word of downscaling to describe this whole process. And also the translated shares and targets, they need to be enabling and incentivizing, and they need to be dynamic and time-bound and also synergetic. I wouldn't go into any further detail than that. Then we shifted to establish a conceptual framework of this kind of cross-scale translation to identify some of the key building blocks and key steps of connecting the Earth system boundaries, which is on the left, to cities and businesses, which is on the right. So here you can see the Earth system boundaries are very often identified as state variables, which, for example, like the 1 degree Celsius, 1.1 degree, or 1.5 degrees Celsius, that sort of thing. But then these things really needs to be transcribed into something that can be shared among the actors. So here is the transcription step. And then with this transcribed budget, we need to allocate them to different actors by using different sharing approaches here. And then the shared translated shares can be used to inform the actors' target setting, and also can be used for benchmarking some of their impact. And together with the understanding of the actors' impact and actors' capacity, then we can really support the target setting. And then in turn, we can do the alignment checking as a whole, whether the individual and aggregated this target can actually ensure us to stay within the safe and just boundaries. And then below this, in this two little house, these are the identified principles that we just talked about. So in this process, it is very important. The sharing approaches will become the key. What kind of sharing approaches you adopt will change, what sort of outcome, outcome being the allocated shares you eventually land on. It will really determine that. So we decided to really look at what are some of the sharing approaches that are used in the literature. So here we reviewed about 40 case studies that specifically actually conducted this translation. And you can see here on the, we have identified on the x-axis here, 11 sharing approaches that are used in literature. And they are used to share different domains, which is on the y-axis, like climate change, biodiversity integrity, land system change, or freshwater use, etc., etc. And then different dots shows, for example, the blue dot shows the end scale of this translation being the country or supranational. And the sort of greenish dot shows that the endpoint is city or municipality. And the red one shows sector or industry. And then we have also companies or product. So here you can see very little study have focused on cities or not so much on companies either, only 2 and 3. So here, each of these 11 sharing approaches, actually, they all carry a normative value judgment, even if they don't explicitly spell them out. For example, legacy, which is sometimes called grandfathering. This is really having the kind of normative assumption that whatever is in the past, that should be respected, right? Whereas if you look at equality sharing approach, that really shows the that it's really based on the normative judgment that everybody should be equal and we should be sharing the resources or responsibilities equally across, us. And then the development right, basically this is trying to prioritize some of the developing countries' right to, enhance their living standard and well-being. So all of these sharing approaches, without one exception, they have inherent and very strong normative sort of assumption. And it is very important that these normative assumptions are made, transparent, made very clear. And these sharing approaches are used in real case translation in different ways, because sometimes we're translating into several different scales, in order to reach the end point. And sometimes it's only one step. And sometimes, we use different sharing approaches in even one scale, and sometimes we use the same sharing approaches across all the downscaling process. And then we try to really come up with a protocol of translation. Can we really develop a kind of common process that a practitioner or someone can actually follow? So we started giving it a try. So here we identified several decision points that are important in doing this protocol. For example, it is very important to know what Earth system domain we're exactly talking about. And there are different, suitable sharing approaches for that. And then the spatial construct is important. Is it globally constructed or is it really regionally constructed boundary? And then the status is important too. Is it already transgressed? Because if it is transgressed, then what you're sharing is the responsibility. And if we're still within the boundary, that means you probably still have some remaining resources. You might be able to divide them up. And then the regenerative nature of the boundary is also important. For example, like water, fresh water, they are recharged annually. Whereas, for example, like ecosystem, if you try to restore that, it will probably take several decades. And where we were talking about climate, the CO2 concentration in the atmosphere, it is not non-regenerative. Basically, if it's up there, then it's up there. And also the temporal perspective is really important as well. Are we trying to look back and then see, trace the responsibility, who caused the problem, or are we going to adopt a more forward-looking, saying, looking forward, what is more important for us when we try to share this, do this translation. And then with all these steps, we can arrive at the selection of sharing, approaches. So this is when we put it into a figure. This is how it looks like. So you start with the Earth system domain, and then you have this traffic light control, depending on these several control point. And eventually you arrive at suitable sharing approaches. Here it says pool of sharing approaches. And then, after the equity and context consideration, you probably arrive at final choice of sharing approaches. And then use that, combining that with enacting metric and data, you can arrive at translated shares. So what we have learned from this process, we see that all sharing approaches and the choice of them in translation really carry implicit, explicit value judgment and uncertainties. And no single translation approach can really address all uncertainties, nuances of context, equality, equity, and justice, etc. And we found that reiterative adjustment is very important and very often needed. And this is another reason why we don't use simply a downscale. Downscale can be one of the first steps, but there are lots of reiterative adjustment that is needed. And transparency is absolutely essential here, because without transparency, we cannot really compare the result of different translated translated shares. And it is very important that we would like to argue for, for whoever doing this translation, use multiple approaches, and they should select the stringent one for target setting. Again, this is because even if you perfectly allocate all the target and then shares, there will be inevitably some people or some actors failing, and we don't want to really risk the failing as a whole. And again, the governance structure is essential because regulations, incentives, accountability, benchmarking, all these things really matter. And of course, cities and companies, they are not existing in isolation or vacuum, and there's a need for a broader and systematic more of a transformation. So here's one example of the complexity of this cross-scale translation. For example, what sort of spatial scale or system boundary you are taking in terms of translation? Are you taking the bioregional sort of approach, or more of a global citizens kind of approach? And each of them, of course, have different, connotation. For example, if you are sharing water, maybe it is sensible to try to do it bioregional approach, but we would like to really emphasize that bioregional approach may sound reasonable, but they're insufficient, and there's a need to be for it to be complemented by a global citizens approach. Because, for example, if you really take this bioregional approach, then you're really rewarding those with natural endowment, whereas you're actually probably penalizing those who are located in water-stressed region or higher population density. And also there might be unintended loopholes as our globally connected production and consumption system means a region can really shift the environmental burden elsewhere. And also it is inappropriate, especially when we are trying to share responsibilities. For example, regions that are rich in biodiversity are very often in the global south. And if we take this bioregional approach, that probably means we are putting the entire burden on this local people or community, while the benefit actually is shared globally. So this is a small example of the complexity of this translation.
𝐒𝐞𝐬𝐴,
So
can I
yeah,
ask?
this is my
We come
final
to...
one.
Thank you.
Yeah. So I think cross-scale translation is really important, and this is one example why this is important. So far, cross-scale translation has only been focused on Earth system boundaries or planetary boundaries. But in this expert voice piece, I have really argued that some of the learning from this translation process can be used to inform, to set specific target for cities and businesses in the next generation of SDG, for example. So I'm not going into detail. If you're interested, please take a look. So thank you very much. And this is an open invitation for collaboration as well. So thank you.
𝐒𝐞𝐬𝐴, thank you so much for taking the time and for giving this really excellent overview into your previous and of course the recent work. This is great. Are there immediate questions for clarification from the audience? By the way, if you see, we have now more than 50 participants. Welcome to you all, Industrial Ecology Day 2024. If not, then let's move on to Frank Lecoq, and we will then have hopefully some time for a common discussion. And the good thing is, 𝐒𝐞𝐬𝐴, you shared all the reference to the papers, right? So please, everybody look them up. Thank you. And then we move over to Frank, please.
Thank you very much. Can you see the slides?
Yes, they're here, and we can hear you well.
Well, thank you very much, Stefan, for the invitation, and thank you very much to all of you for being present. What I would like, the paper that I'm going to present was co-written with Professor 𝐒𝐫𝐬𝐴 from the University of Cape Town. He couldn't be here today, so it's really a joint work. It's kind of a narrower point than the one that was made before, but actually it follows quite nicely. In a sense, what we are warning is the risk of when the translation is not made with adequate transparency. So the motivation for this paper was actually when Harold and I were co-writing a chapter for the latest IPCC report, and reviewing the literature, we saw a lot of papers that had mitigation scenarios for, say, countries by 2030 or 2050, but also for cities, for regions, for sectors. And these scenarios were often labeled like 1.5C scenario or 2.2 degree scenario, Paris compatible scenario. Yet those were scenarios for just one city or one sector. And so the relationship between the emissions of one single actor like this and global temperature at the end of the century was clearly not was not clear at all. At least there were elements missing from these papers. We made the point that there were these labelings were incorrect. We thought there would be a paper somewhere that would make that point. We did not find it. So after we had published our chapter for the IPCC, we actually wrote the paper in climate policy. So this is a very basic point, but which we think is important because, as I will try to show, mislabeling can be dangerous. So the basis really for the argument is that there is a near linear relationship between cumulative anthropogenic CO2 emissions and the global warming because this is working group 1 of the IPCC. And this relationship you can see on the graph on the left-hand side. On the x-axis, you have cumulative carbon dioxide emissions since pre-industrial time. On the y-axis, global temperature increase relative to pre-industrial time in 2100. And you see the quasi-linearity between the two. So the point is that warming in 2100 depends on global emissions, past and future, and certainly not on those of a single actor, be it a city, a sector, or even a single large country. to see that on yes, in a to see that if you take so to simplify basically the drawing, you can see that well, temperature in 2100 depends on all the CO2 that you have emitted since pre-industrial time. So this is really but now if you what does it mean for, how does it relate to a single actor's emissions? Well, first you have to divide the past and future emissions. We're talking about, it's the total emissions from since pre-industrial time. But typically the actor you're considering, your city, your country, even represents a tiny slice of that total budget. This is at the bottom. The rest of the world emissions will be bigger. Even more so, if you're in fact what we were really seeing in the literature were labels for mitigation scenarios from now on to 2030, on now on to 2050, typically. So the tiny little box, red box at the bottom of the screen. And as you can see, there's really no direct relationship between this little red box and global temperature in 2100. Or said differently, if you argue that there is a relationship between the two, implicitly you're making big assumptions about your future emissions as one actor, and even more so assumptions about the emissions in the future of the rest of the world, meaning that de facto you're making assumptions about the distribution of the efforts between you and the rest of the world from now to 2100, and therefore you're making equity assumptions, which typically were not transparent, not present in the literature that we were reviewing. So this is another way of making again the same point. The actor's emissions, even if you're considering its past and future, are small relative to the emissions of the rest of the world. And also note that if you're talking about 1.5 C, for instance, as much of that it depends not only on future emissions but also on the past. So the equity component relates not only to future emissions but also to past ones. So the conclusion that we were drawing, I mean, the recommendation that we were drawing from this again very simple point is that one should avoid labeling mitigation efforts with long-term temperature goals, or ideally, because that relationship is basically nearly always meaningless. Even more so, what we are labeling mitigation pathways with long-term goals might also temperature goals, sorry, might also be misleading. De facto, when you have a scenario and when you present a scenario, the way that scenario is labeled, it matters. And labeling a scenario 1.5 C, for instance, can actually be interpreted as making the claim that this particular emissions pathway is indeed the right budget that you should have under global 1.5 objective. So in a way, it can be interpreted as a claim for this is my right budget or my right contribution to the global effort. Also, we have seen actually in the media some of these scenarios being misinterpreted and countries blamed for long-term temperature effects. For instance, a recent article by 𝐒𝐤𝐬𝐿 and 𝐂𝐵𝐺 did try to associate mitigation efforts at country level with long-term temperature goals. They did so providing information, clear information on time, on space, on equity. So they met the conditions that we will see afterwards that we think are the necessary conditions if you really want to label, at least be very, very transparent about your assumptions. So they made these assumptions in their paper, but then this was translated in a newspaper article as simply pointing to the finger towards country and saying, "Oh, you're responsible for 4C or 5C of 5C of temperature at the end of in 2100," without at all any clarification of the assumptions that were behind. So there's really a risk. There's really a risk when you put labels like that they be misinterpreted. Yet we could have ended the paper there, but of course there is a strong demand for labeling. So what we sort of argue in the paper is that if you really cannot resist labeling mitigation scenarios for single actors with long-term goals, then you should really make very explicit, consistent and defensible assumptions about time. So, okay, how much will you emit beyond 2030 or 2050? Space. So how much are you assuming the others will be emitting from now to 2100? And therefore equity. What is what is the implicit equity principle that you're using to allocate both future but also past emissions between you and the rest of the world? Again, if you don't do that, there's a risk of a simplification and a risk of ascribing to one actor what is the responsibility of all collectively. Really, one should make, and I would like to insist on the equity part, again, echoing the previous presentation, because it's really, really central to make explicit the distributional principle that relate one actor's emissions to the emissions of the rest of the world. Are you using de facto per capita emissions? Are you allocating emissions efforts, mitigation efforts, so based on efforts, emissions intensity, whatever? As we saw before, there are many possible sharing principles which carry very different normative assumptions, and one should be clear about what is being used, taking into account the fact that some of them are less notably consistent with international law, and notably favoring an ISIE, as other papers, Rajamani et al. 2021 suggest. So this is, we really think this is still second best, and one should avoid labeling as much as possible, but at least maybe complex enough so that it's not misleading. To sum up, two key messages for researchers: please avoid labeling as best as possible, and if second best, really be very consistent and clear about the assumptions that your underlying assumptions. But also for media and NGOs, people who actually use some of these scenarios coming from the academic community, don't oversimplify for messaging, and check whether the studies actually are crystal clear about the assumptions they make. And those that do not, really just leave them aside. And maybe to conclude, I think it's also there is also a tension, fundamental tension between that ascribing collective goals to individual actors. Climate mitigation, it is a problem of collective action. And labeling mitigation action by single actors is de facto at odds with this collective dimension of the problem. And so maybe there's also a way to think differently and encourage companies, cities, etc., to think collectively and to have a conversation about how collectively they can act and not just individually. Well, there's I encourage you as well to read the paper if you are interested as a little more details. And with this, thank you very much.
Frank, thank you so much for this presentation. So you really see the tension, right? On the one side, 𝐒𝐞𝐬𝐬 said there is the need of actors to have such handy targets. On the other side, each contribution is tiny, right? And if everybody has different scaling principles, things won't add up again. So now we really have set the stage. Let us also now switch to Hayoung's critique and presentation, so we can also have your input, Reinhard. Sorry, not Reinhard, Hayoung.
Yes.
And then we have a few more minutes for discussion. And of course, this will be only a very first start of a discussion. More has to follow up, but at least we have set the stage. So I think, Reinhard, you can directly share and continue. Thank you.
Right. Is this working?
It's working, and we can see and hear you well.
Okay, great. So thank you for joining and thank you for inviting me, Stefan. So I was invited on the basis of the title, Life Cycle Assessment-Based Absolute Environmental Sustainability Assessment is Also Relative, on the basis of a paper that 𝐒𝐬𝐬𝐿 and I wrote 2 years ago, together with 𝐈𝐧𝐬𝐭𝐢𝐭𝐰. Actually, 𝐒𝐬𝐬𝐿 was invited, but he couldn't make it, so I'm here. But this is a paper 2 years ago, and actually I think the message was not taken, because we have quite some harsh conclusions, but in the end people go proceeding in the way they did before. So what I did in the end, so let me see if it's not, yeah. So this is the paper where the link in the invitation is about. So in the end, I changed my title to this one, which I hope is a little bit more provocative and also more clear what the message is. It's about the myth of absolute LCA. And as you can see from the original title and from the new title, it's about life cycle assessment, LCA. So my focus is not on, let's say, on cities or countries like we have seen in the previous 2 presentations, but it's here on products throughout their life cycle, because I think that is a thing that is really a little bit overstretched. So it's important to emphasize the myth. And one of the things that has come up, and this is an impressive list of authors that Anders Björn has put together in reviewing all these life cycle-based methods for absolute sustainability assessment. And actually, I was also to some degree involved in this group, but at some point I stepped out because I was not very happy and I was a bit negative, perhaps. So in the end, if you go to this article, I mean, it reviews many important things, and I don't agree with that. And one of the things that they do is they define, I will not read this aloud, so don't be afraid, what is a relative sustainability assessment and what is an absolute sustainability assessment. And also because they focus on life cycle, although not life cycle assessment, but life cycle based. Okay, well, they come with things like relative means that A is more sustainable than B, and absolute means that, for instance, that option C is sustainable and so not in a comparative way, but that is sustainable or not. And our position has always been, well, that is not the way forward to go. So the thing that I already showed is arguing against that. And it has a key phrase, which is there is no such thing as absolute LCA. And we have, of course, arguments for that. And I will go into some of these arguments today. Actually, this is quite an old message. So already in 1992, we wrote one of the first ever guidebooks on LCA, which ended the preface with a sentence that there are no environmentally friendly products, but that some are more environmentally friendly than others. And of course, you might translate this into more sustainable than others. So what I will do is I will give you 4 arguments why I will also present a couple of counter arguments to show the fair side. So not only the negative side, but also, well, how you can beat me. But as a spoiler, I would say there are more arguments against than there are counter arguments. And also one thing that you might observe in countering these arguments is that gradually LCA turns into another type of analysis, which I would not anymore recognize as life cycle assessment. So in that sense, it's also, even if you would have more compelling counter arguments, you may wonder in the end if you are still doing LCA or if you gradually have changed to some other types of field. Okay, so argument number one is size matters, and I think everyone knows what that means. So typically you see, well, this is a typical picture from an advertisement for a car. You see a lonely road with one car and it's all very beautiful. And I would say, well, this is a very sustainable situation. One car is sustainable. But reality is, of course, different. And you see these types of phenomena. And that's what I mean with size matters, because if one car is sustainable, but 1 billion or 1 trillion cars is not sustainable. It's the same car, it's the same functional unit. The relative sustainability of one car versus another car is likewise, but in absolute terms, of course, it's a different thing. Now, that's my first argument, size matters. And of course, you could go and say, okay, yeah, but we can actually beat you. Go for realistic functional units. So that means not 100 kilometers of driving, but the real number, which is 10 trillion kilometers or something like that. And then you get a different picture. And well, that is some fair argument. And of course, we had to think for a while before we could come up with a second counter argument. So the second counter argument is that you have lost time at some point. Because, well, this little bit hypothetical example, there's a planetary boundary for CO2 in terms of 350 ppm. And well, I don't know exactly what the translation is into the flow of CO2, the annual budget of CO2, but suppose it would be 200 gigatons. And then you see there's a per year in this flow of CO2. And typically it ends with not with kilograms per year, but with a kilogram thing. And so there's incompatibility in time. So LCA typically loses time along the way. And if you would, because you have lost it, you don't know how that would work out. So that's the second counter argument that we come up with. And then, of course, there's an obvious repair for that. Well, include the time, and that's, of course, the real time in the functional unit. So do not go for 10 trillion kilometers, but for 10 trillion kilometers in 1 year. And then again, you have set included time again, and then things will work out fine. Okay, that's argument number two. Let's have a further look. We had to think about, okay, how still we're not convinced. So what is actually going on? And we came with the third one, and that is the real relativity of time. And I'm not speaking about, let's say, the meaning of that. But what I'm speaking about is this type of picture. And actually, this is one of the graphs which is in our original article. That we say, okay, take a typical product, and on the horizontal line we have the time, and you have a certain product, and you have a lot of emissions during the production of the product, and that's the blue thing. And of course, you need upstream some emissions as well for the production, and that's the green things. And then that's spread over time, and then you use the product for a couple of years, and then perhaps you use it every day for a while. So you have some time pattern. And if you would do this, and of course you see on the vertical, it's kilogram per year. So now we have included time to solve argument number two. And now let's go for the absolute thing. Well, there may be a threshold also in terms of the maximum tolerable flow. But you can see that at some point we overshoot, but most of the time we do not. And so this is not a clear thing. If you say, okay, are you within this threshold, within the boundary? It's not, you can say yes or no. It is, well, yeah, there's occasionally you overshoot. But of course, if you would squeeze it all into this thing, you come lower. So this is not a very clear thing. And there's some incompatibility going on. Well, again, a third counter argument comes up. Well, yes, it was for a single product, but if you assume a steady state, products every second, and new products produced and used, etc., then all these things will average out, and that will well. Some people have been doing that in the form of fleet-based LCA, and even try to connect this to some absolute sustainability things. So attempts have been going on. Finally, we came up with argument number 4, and that is it's a life cycle. And this sounds so obvious that people think you are fooling them. But the essential point of the life cycle is that it consists of a couple of processes, unit processes. And even if you would take a realistic functional unit with the correct time, that means that only one of the processes in this life cycle is included in its correct volume. So for instance, if you take driving cars, and you can include it in the full picture. But if you take one of the upstream things, like the refinery, refining the oil and making the gas, that is not included in its correct volume because part of the refinery is not fueling cars, but some other product. So if the driving cars is included fully, then the refining oil, which contributes to that, is not included fully. And in that sense, you miss certain things which define if it is an absolute thing or not. Well, yeah, so countering argument number 4, basically I'm speechless because I think you can't. This is the essential criterion of LCA, that it is a life cycle and some of the processes are not included in their full extent, and there's no way to solve that. Otherwise, you step out of the LCA. We've been debating this argument actually before in a slightly different context when we were discussing the tension between LCA and the risk assessment that we did in Nature Nano publication, but also long ago in 1993, when there was no correct, no scientific journal yet devoted to these topics. So it has a long history, but I think it still holds. But now we have extended this argument from risk assessment to the absolute things, and including also the planetary boundaries. So my conclusion is LCA and this absolute environmental sustainability assessment are incompatible, and fundamentally incompatible, in the same way as life cycle assessment and risk assessment are incompatible. And well, the reason is you need real volume. But in LCA, you don't have real volume. That is a real thing. In that sense, I would argue that do not use words like absolute LCA and life cycle-based absolute environmental sustainability assessment, because they are just misleading and they think you can prove that a product is sustainable. And my argument is no, you cannot. And we conclude by saying that there is no such thing as absolute LCA, and therefore do not use that term. Still, this session is about, well, limits of downscaling. And of course, we can discuss that for actors, like in the previous presentation, and also perhaps for cities, like in the presentation before. But I would say, in the terms of LCA, don't do that. It is just an amusing myth, and we don't go for that. And it's a little bit comparable to the old discussions about how many angels can dance on a needle tip. And I would now phrase it, we can discuss also the pros and cons of having a unicorn as a pet. But of course, unicorns don't exist, so it makes no sense to discuss that. But, and then comes the positive conclusion, we can still use elements from this discussion into the LCA field. And I will give a couple of examples. For instance, we can learn from the planetary boundary discussion about, okay, perhaps we have forgotten certain impact categories and we can learn from that, or perhaps the planetary boundary peoples have forgotten about some important impact categories. And I think indeed they forgot some important impact categories. So there is a mutual learning, I would say. Also, we see various attempts to to align these impact categories in LCA and in the planetary boundary fields, some more and some less successful. I refer to one article here, which is showing a diagram in that sense. And the final thing is that the weighting or prioritization of impact categories can also be inspired by absolute considerations by the planetary boundaries, like you see, for instance, distance to target methods, like we see in the 𝐕𝐺𝐸𝐾𝐬𝐻 et al. Methods for the eco-scarcity. My final thing is I would like to connect this also to the IPAT equation, which is coupling the population, affluence, and technology to the impact. And I would say, okay, population and affluence, that's the size, and you know size matters, and the T is only what the LCA is doing. So there's a very clear separation between the LCA and the absolute impact. So that's it. Thank you for your attention, and I'm very eager to hear your comments.